Okay, so we are going to take a look at function inverses again, but this time we're going to look at how to find an inverse. So the previous video that was labeled function inverses was checking to see if two functions were inverses of each other. Now this process is how you actually go through and find an inverse given one function. So finding the inverse of a function, the x and y values are swapped. Then the function is resolved for x. So inverses are about information. If a function can be inverted, reverse a procedure, that means that no information is lost when that function is applied. So not all functions can be inverted. Sometimes information is lost within the function. So for a given one-to-one function, f, there is a related function f of -1, which is the inverse of the function. So that's literally how we read it. It's the inverse of function f. So the function f maps x to y if and only if the inverse of function f maps y to x. So the outputs of f are inputs of the inverse of f, and vice versa. So you can kind of see this back and forth. So we have these two pieces. So again, the outputs of f, the original function, are the inputs of the inverse function. So I know that's kind of a interesting wording there. So more precisely, we have the inverse of function f of y equals x if and only if y equals the function f of x. All right, so that's, a whole lot of math verbiage there. Let's go ahead and kind of see how this works. So we're going to use the one-to-one functions g and h, and they're defined below here. So one of them, they're going to give us the expression that the function equals, and the second one, they're going to give us the actual coordinates for the function. So for the first one, if I want to find the inverse, because that's what they're asking me here, find the inverse of g, then I'm going to swap the x and the y. So remember, I can switch function notation back to y. So this means y equals x plus 2 equals 11. So I've written it up here. So I'm going to swap x and y. That's the first step. And now I'm going to resolve for y. That actually, I just realized that should say y in there. Resolve for y, not for x. Okay, so we're going to multiply by 11 on both sides because I want to get this 11 out from underneath here. So the 11's cancel, and I have 11x equals y plus 2. I'm going to subtract 2 from both sides. So I have 11x minus 2 equals y. So the inverse of our original function g is 11x minus 2. So that's how we go through and find the inverse. So now we're going to check the composition of the two. So we have the inverse function of g, and that's composed of the function g of -2. So it's asking us to plug -2 into the function g, and then plug that result into the inverse function. So let's go ahead and do the first piece here. And again, there's videos. I have a couple of different videos on compositions of functions. So if you're not quite sure what I'm talking about there, go back and watch those videos to understand what a function composition is. So first, we have g of -2. So we're using that original function they gave us. So x plus 2 divided by 11. So -2 plus 2 is 0 divided by 11. Well, that's still 0, right? So this is the result of g of -2. I'm going to take that result and I'm going to plug it into the inverse function we found up above, which is 11x minus 2. So now I have 11 times 0 because that's our x, our result from the previous function, minus 2. Well, 11 times 0 is 0, minus 2 is -2. So this shows that we ended up back at what we started with. We started with our input of -2, and our output is back to -2 for 1. So our input and our output are the same for each. So one thing I wanted to know, do we really need to do all of this work? The composition, so what that means is if I'm looking at the composition of these two, which we can either use that little open dot there, that means the composition, or sometimes they'll use double parentheses where it'll say, g of -1, comma, parentheses g, parentheses, -2, end parentheses. So they'll use, double parentheses there. So there's two different ways they can note compositions. So the composition of a function with its inverse always gives an output equal to the input. So that means that g of -1, or the composition the inverse of g and g of -2 will result in -2, because it is a function that results from being put through its own inverse. It undoes what just happened, right? So we go through and we do g of -2, and then when we do the inverse of g, that completely undoes the things that we just did. So it comes right back to what we started with. Remember, inverse reverses the function. So it's just that idea. No matter what, as long as I'm using the composition of an inverse and its function, it's going to come back to whatever it started with. So I really didn't need to go through and do all that work. That was kind of, the short way, or the long way of saying that. All right, so let's go ahead and look at the second one here. So they want us to find the inverse of h at 1. So with this one, I don't have an expression or an equation where I can switch x and y and plug this in, but I do have coordinates. So what I'm going to do is I'm going to swap each coordinate with x and y. I'm going to do that for each one. So you can see I'm just switching the places for x and y. So they're just backwards. And then I'm going to identify which one has x as negative or as 1. So it's this very last one. So the answer would be 8. So that's when they give you the coordinates like that, you just want to swap them, x and y. So y becomes x and x becomes y, and do that for each and every one. And whatever number they're asking you to identify, you identify it after you've swapped them all in the x position. Okay, so there is a 1 here, but that's a y. I want when x is 1, what do I get for the function? I get 8. All right, so that is finding the inverse of a function. I hope that helped, and I will see you in the next video.